This is Unit 3, Day 1, Quadratic Functions Review. Example 1, without the use of your calculator, evaluate each of the following quadratic functions for the specified input values. Recall that according to the formal order of operations, exponent evaluation should always come first. Okay, so our first function here, part A, is x squared. Remember, anytime you have a negative number, when you substitute it in, you need to use parentheses. And negative 3 squared is 9. Okay, positive numbers, no parentheses necessary, so you get 25. Okay, second one, again, don't forget to apply order of operations, so I have to substitute in a 2. So it's 2 times 2 squared minus 5. So order of operations, I have to do the exponent first, so 2 squared is 4. Okay, and now I'm left with multiplication and subtraction. So 2 times 4 is 8. Minus 5, I get 3. Okay? Again, be careful because when you have a negative number, so part B here, g of negative 1, I have to plug in that negative 1, so make sure you're using parentheses. So it becomes 2 times negative 1 squared minus 5. So it becomes 2 times 1 minus 5 is 2 minus 5, which is negative 3. Alright, last one here, part C, plugging in negative 2. So it's the opposite of negative 2 squared plus 4 times negative 2. Now remember, guys, the exponent here is negative 2 squared. Well, negative 2 squared is 4, but then you carry down that negative with it. So anytime there's that negative on the outside, it does result in a negative here because this squaring is positive, and it basically means the opposite of x squared. Okay, continue on, that's minus 8, and then that results in negative 12. Okay, so opposite of 3 squared, use parentheses that time just because that negative out front, plus 4 times 3. So it becomes negative 9 plus 12. And negative 9 plus 12 is the same as 12 minus 9, which is going to be 3. Okay, pretty easy. Again, don't forget you can use your define key, which is menu 1, 1, and you just define the function, and then that would check out in your calculators as well. Alright, the important text box here, it says quadratic functions. A quadratic function is any function of the form f of x equals ax squared plus bx plus c, where the leading coefficient a is not 0. Graphs of quadratic functions form what are known as parabolas. Okay, a couple little things you can't forget here. If your leading coefficient a is positive, you guys know that the parabola opens up and there's a minimum. Okay? If the leading coefficient a is negative, then the parabola opens upside down and now there is a maximum. Okay? Example 2, consider the simplest of all quadratic functions. This is actually the parent function, meaning nothing happened to it. We didn't shift it up, down, left, or right. And it says create a table of values for over the domain. Now remember, it only wants from negative 3 to positive 3 for the x values. That's my restricted domain there. Okay. Okay, so now all you're going to do is negative 3 squared is 9, negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. Okay, sketch a graph of this function. Alright, so I'm just going to plot these really quick. And if you guys recognize that you know that this is going to be symmetric, okay, now the only thing you have to be really careful on, because it gave a specific domain, you cannot draw arrows, okay? Do not draw arrows. Because it gave that domain, no arrows can be drawn. You will actually lose credit on a Regents exam if you were to draw the arrows in, because that's saying you're not recognizing that the domain is from negative 3 to positive 3. And then I just usually throw a little label on there. Okay, part C, state the coordinates of the vertex. All right, well, the vertex is its turning point right there. There's my vertex down here, so it's at 0, 0. State the equation of the parabola's axis of symmetry. Well, the axis of symmetry is the line that divides the parabola through its vertex, through its turning point. And remember, guys, all those equations are always in x equals. Well, in this case, we're at x equals 0. So my axis of symmetry is x equals 0. So, for example, if it was over here, it's going to be x equals 1. Okay, if it's over here, it would be x equals negative 3. Over what interval? Okay, so you should be using, thinking of the range here. Not a range, I'm sorry, a specific from where to where. Is this function increasing? Okay, so it's increasing from 0 to 3. Okay, so something you look at, it's from here to here. So you're looking at these x values down here, if you can see me shading in red here. So it's from 0 to positive 3. Okay, and they're both included. So you can give me 0 less than or equal to x less than or equal to y. I'm sorry, 3. Or it could be 0 to 3. Okay, it's increasing. It means the y values are going up. Okay, be careful, that's different than positive. All right, example 3. Consider the quadratic function f of x equals negative x squared plus 6x plus 5. So some things just to pay attention to, guys. You know that this is opening upside down because your a is negative, so there's going to be a maximum up top. Your turning point is a maximum. Use a table on your graphing calculator. Determine the vertex of this function. Okay, so now, guys, you got to be careful. When you put this whole equation in your graphing calculator and then you press Control-T to enter in the table, you're going to see a bunch of x's listed and a bunch of y's. Okay, you want to look for the pattern. Okay, so you have to look for the pattern. So again, just going to the graphing calculator, you learn that your turning point is at 314. Okay, and again, looking for the pattern. The pattern means on your table, you want to start seeing where the y values start repeating. So if they're constantly going up or constantly going down, then you didn't find that pattern. So things should start repeating themselves. Okay, so 314 is its turning point, and then we have a bunch of other points here. And I'm just sketching a bunch of them. Now this didn't give a specific domain, so you're going to see that I am going to draw in this parabola, and I am going to show arrows at the end, because again, it was not stating a specific domain. So this is my y equals negative x squared plus 6x plus 5. Always label. What is the range of this quadratic? Now remember, range means y. It means the highest and the lowest. Okay. Now you do have to order it from least to greatest. So my lowest has arrows down here. And because it has arrows, it means it's going to be approaching negative infinity. And infinity is never included. Okay. My highest point is 14. And 14 is included. That's up top. Okay. So remember, guys, yes, this is at 14. So that's the high. You go over and you're at 14. Okay. All right. Part C. Graph this function on the grid to the right. Oh, I already did all that. I'm sorry. I guess I did that in part A. Part D. Why does this parabola open downward as opposed to y equals x squared, which opened upwards? Because A is negative. Okay, so we had a negative x squared, so that's why it opened up. Okay, between what two consecutive integers does a larger solution? Remember, guys, solution, and they're talking about when it's 0. That's y. So in your brain, when y is equal to 0, that's talking about the x-intercepts. Okay, or just even that word solution means x-intercept. So there's two x-intercepts on this graph. It's here and here. Okay. And it says between what two consecutive numbers. So if I go over here, between here and here would be the larger of the two. So that's 1, 2, 3, 4, 5. It's between 6 and 7. So between 6 and 7. What does this point represent? Again, the x-intercepts, also known as roots or zeros. Okay. Example 4. A sketch of the quadratic function y equals x squared minus 11x minus 26 is shown below, marked with points at its intercepts and its turning point. Using tables or a graph on your calculator, determine the coordinates for each of the points. Okay, so basically make sure you guys remember to go put that whole thing in your graphing calculator, and then you're going to need the table. Now, x-intercepts are when y are equal to 0. Y-intercepts are when your x are equal to 0. So once you insert your table by putting Control-T on your graph page, for the x-intercepts, look on the graph, and you're going to want to see when y, so if you have a little chart here, here's your x, here's your y, you want to look and see when y is 0. And where y is 0, look over and see what that number is, and that's going to tell you what your x-intercept is. Okay, so on the graph, it ends up being -2, 0, and then there's also a 13, 0. So now you do have to look, and again, you're looking to see when y is equal to 0. Okay, so my point A, x is at -2, and my B, x is at positive 13. Okay, you can give them as coordinates too, so it's -2, 0, and 13, 0. Okay, y-intercept, you're trying to figure out where this is crossing over the y. So in your chart, it's where x is equal to 0. So when x has a 0, you're going to look over here and see what that number is right there on the y, and it ends up being -26. So the y-intercept is at y is -26. Again, it has a coordinate of 0, -26. Okay, turning point. The easiest thing for me to do, now most of the kids looked on their tables here, and I think, if I can remember this correctly, it was between 5 and 6. I think it looked like this, maybe, I'm hoping, if I remember correctly. And the kid said, you know, there's no pattern. Well, yeah, it happens to fall between here. Now, you can't assume it's exactly in the middle between 5 and 6 and tell me it's at 5.5. But what you can do is you can use your calculator. And on your calculator, if you hit menu and then you analyze the graph, there's an option that says minimum or maximum. So this one, in this case, has a minimum. And then what it does is it makes you highlight the bounds. So you have to hit enter and click. And you're going to set the bounds, and it becomes shaded in this whole region right here. And as soon as you picked your left bound and your right bound, and you hit enter, all of a sudden you get an intersection point that appears. And it tells you that that intersection point, I can actually draw it up here, it tells you that that intersection point is at 5.5 and then -56.3. Oops, they were 56s, not 53s. Okay. On what interval is this function positive? Now, you guys are having a hard time remembering this. Positive means it's above the x-axis. Okay, so where does this graph fall? Above the x-axis. So, if I look right here, this is where it is above the x-axis. Okay? So it is above the x-axis, and again, you're looking for anywhere above. So where I shaded in yellow is where it's above the x-axis. Now you know these points right here. This is the point -2, 0, and then B is the point 13, 0. Okay, so it is going to be from -2 down. Okay, so this falls from -2 and lower, and this falls from 13 and higher. So what interval? It's going to be from -infinity to -2, and it's also going to be, I'm sorry, I can include that one, and it's also from 13 to positive infinity.